Welcome, parents, to KOEIGO STEAM plus Language School's STEAM program at Zion Christian Academy International. We're thrilled to have you join us as we take a deep dive into the exciting world of Arduino, alongside your children, of course.
It's fantastic to have you here.
So this deep dive is all about, well, giving you a glimpse into what your kids are experiencing in our STEAM program this week. They're tackling a project that, well, it might sound simple, but it's packed with learning. Building a traffic signal using the Arduino UNO R3 board.
Yeah, this project is a fantastic way to introduce, those fundamental concepts of coding, electronics, and, problem solving. It's amazing to see how engaged the students get.
I bet. It's way more exciting than just, reading about circuits in a textbook. But before we get into the nitty-gritty, can you remind us what the Arduino UNO R3 board actually is? I always picture it as like a tiny brain controlling things, but maybe that's oversimplifying it.
That's a pretty good analogy, actually. The UNO R3 is essentially a miniature computer, but instead of browsing the internet, it excels at interacting with the physical world. It can receive input from sensors, process information, and then control things like lights, motors, and even sounds.
Okay, so it's like the brains behind their traffic light, telling it when to, switch between red, yellow, and green. Now, I know LEDs are involved, those little lights that make the traffic signal, come to life. What else goes into making this thing work?
Well, aside from the LEDs, we have resistors. These are crucial for regulating the flow of electricity. Think of them like valves controlling water pressure. Just as too much pressure can burst a pipe, resistors ensure the right amount of electricity flows to the LEDs, keeping them safe and functioning properly.
That's a great analogy. I can see how that would be important.
Mm-hmm.
So we've got the Arduino board as the brain, LEDs as the lights, and resistors acting as safety guards. What about the actual building process? Where do they even start?
We actually begin in a virtual world using a program called Tinkercad. It's a fantastic platform for students to design and test their circuits digitally before they start working with the physical components. It's like a digital sandbox where they can experiment freely without the fear of breaking anything.
That makes a lot of sense. So they build a virtual version of the traffic signal first, and then they bring it to life in the real world.
Yeah.
What's that transition like? Is it just a matter of copying what they did in Tinkercad?
It's a bit more than just copying. They still need to assemble the components on a breadboard, connect the wires correctly, and make sure everything is powered up properly. But having that virtual experience in Tinkercad, it gives them a huge head start.
I bet it makes them feel more confident when they're handling the real components,
Right.
knowing they've already tackled the design challenges virtually.
Absolutely. It really empowers them to take ownership of their learning. But the real magic happens when we start programming the Arduino board. This is where they get to breathe life into their creation, telling it how to behave, how to control the lights, to mimic a real traffic signal.
Okay, so this is where the coding comes in.
Mhm.
And I'll admit, coding always makes me a bit nervous. It feels like I'm talking to the computer in a secret language. But I'm guessing it's not as intimidating as it seems, especially for the kids.
You'd be surprised how quickly they pick it up. The Arduino language is actually designed to be relatively intuitive, and before they even write a single line of code, they learn to think like programmers by using something called pseudocode.
Pseudocode. That sounds intriguing. Is it like a secret code for beginners?
Not exactly. It's more like a rough draft of their program, written in plain English. Imagine a choreographer's notes outlining the steps of a dance before the performers bring it to life on stage. Pseudocode is like that. It helps them break down the problem into smaller, manageable chunks.
So instead of jumping straight into the technical jargon of coding, they start by mapping out the steps in a way that makes sense to them.
Precisely. For example, they might write something like, turn the red light on for 5 seconds, then turn it off, then turn the yellow light on for 2 seconds, turn it off, and finally, turn the green light on for 5 seconds.
Ah, so they're basically creating a step-by-step guide for how they want the traffic signal to behave.
Exactly. And once they have that pseudocode in place, translating it into the actual Arduino code becomes much easier. They learn to use commands like digital write, which controls whether an LED is on or off, and delay, which pauses the program for a specific amount of time. These commands are like the building blocks of their code, and they can combine them in different ways to create all sorts of patterns and behaviors.
This is fascinating. They're not just learning to copy and paste code. They're actually understanding the logic behind it, the sequence of events that, makes a traffic signal work. What are some of the challenges they encounter in this process? I imagine getting the timing right can be tricky.
You're absolutely right. Figuring out the right duration for each light, making sure the sequence is correct, that's where the real problem solving comes in. They might start with their pseudocode, but then they have to tweak the code, experiment with different timings, and debug any errors that, pop up. It's a process of trial and error, but it's incredibly rewarding when they finally get it right.
I bet there's a huge sense of accomplishment when their virtual traffic light starts flashing in the correct sequence.
Definitely. And it's coming next week. They're going to take it up a notch by adding a pedestrian button to their traffic light. This introduces a whole new layer of complexity, as they'll need to make the traffic light respond to input from the outside world.
Hold on, a pedestrian button. So it's not just going to be a simple loop of red, yellow, green anymore.
Not at all. They'll be using a push button. That, when pressed, will signal the Arduino to change the traffic light sequence, allowing pedestrians to cross safely. It's a fantastic way to introduce the concept of input and how computers can react to the physical world.
That sounds like a real game changer. It's suddenly becoming much more interactive and realistic.
Exactly. And to achieve this, they'll be learning about conditional statements. These are like decision points in the code. If the button is pressed, do this. If not, do that. It's a fundamental concept in programming. And it opens up a whole new world of possibilities.
Wow. I'm already impressed by how much they're learning from this seemingly simple traffic signal project. It's clearly way more than just connecting some wires and LEDs.
It truly is. They're gaining valuable skills in problem solving, logical thinking, and creativity. But beyond the technical skills, they're also developing a growth mindset, learning to embrace challenges and persevere through difficulties.
That's a powerful takeaway. So it's not just about building a cool gadget. It's about fostering a love of learning and a passion for exploring the world of technology.
Absolutely. And as parents, you play a vital role in nurturing that passion by showing interest in their projects, asking them questions, and encouraging their exploration. You can help them connect their learning to the world around them and ignite their imagination for what's possible. It is, and it's not just about the technical aspects. This project also encourages them to think, systematically, to break down a complex task into smaller, manageable steps.
You're talking about that pseudocode again, right?
Yeah.
The planning stage before they dive into the actual coding.
Exactly. And that skill, that ability to think algorithmically, that's invaluable, not just in programming, but in so many aspects of life.
I can see that. It's like planning a trip, breaking down into destinations, routes, packing lists. It makes the whole process less overwhelming.
Precisely. And when they encounter a problem, they learn to troubleshoot, to analyze the code step by step and identify where things might be going wrong. That kind of analytical thinking is a powerful tool.
It sounds like they're developing a real detective mindset, hunting down bugs in their code.
You could say that, and the satisfaction they get when they solve a tricky bug, when their traffic light finally behaves exactly as they intended, it's priceless.
I bet it's a real confidence booster, knowing they can figure things out even when they hit a snag.
Absolutely. And that confidence spills over into other areas of their learning. They're more willing to take risks, to try new things, and to persevere even when faced with challenges.
That's fantastic. So this Arduino project isn't just about learning to code. It's about building a foundation for lifelong learning and problem solving.
Precisely. And it's also about igniting their curiosity about the world around them. Traffic lights are something they see every day, but now they're starting to understand how they work on a deeper level. It opens up a whole new way of seeing things.
It's like they've peeked behind the curtain and discovered the magic that makes technology tick.
Exactly. And that spark of understanding, that sense of wonder, that's what we aim to nurture in our STEAM program.
So they're not just passive consumers of technology anymore. They're becoming creators, innovators, problem solvers.
That's the goal. And the best part is that this is just the beginning. Next week, they'll be adding that pedestrian button we talked about, taking their learning to a whole new level.
I'm excited to hear more about that. It sounds like it'll really challenge them to think outside the box.
It will. They'll need to consider how the traffic light should respond to input from the button, how to create a safe and efficient system for both vehicles and pedestrians.
It's like they're designing a mini city with all its complexities and interactions.
You could say that.
Yeah.
And in the process, they'll be deepening their understanding of programming concepts, learning about things like interrupts and state machines.
Interrupts and State machines. Okay, I'll admit, those sound a bit intimidating.
Don't worry, we'll break them down into manageable chunks. Think of interrupts as unexpected events that require immediate attention. In the case of the traffic light, pressing the button triggers an interrupt, forcing the Arduino to pause its regular routine and address the pedestrian's request.
So it's like a sudden detour in the flow of traffic.
Precisely. And state machines help manage the different modes of operation. The traffic light can be in a normal state, cycling through red, yellow, and green. But when the button is pressed, it transitions into a pedestrian crossing state with a different set of rules and behaviors.
It's amazing how something as seemingly simple as a traffic light can involve such sophisticated concepts.
It is, and that's the beauty of it. It allows us to introduce complex ideas in a way that's engaging and accessible.
So they're not just memorizing definitions, they're applying these concepts in a hands-on real-world context.
Exactly. And that's what makes this learning experience so powerful.
All right, we're back, ready to tackle that pedestrian button challenge. It sounds like this is where the project really starts to mimic real-world traffic systems.
Absolutely. Adding the pedestrian button introduces a whole new, level of interactivity and complexity. It's no longer just a simple loop of lights. Now the system has to respond to external input and make decisions based on that input.
I remember you mentioned something about interrupts and state machines. Honestly, those sound a bit like sci-fi jargon to me. Can you break those down in a way that even a, non-techie parent can understand?
Of course. Imagine you're reading a book, completely engrossed in the story. Suddenly the phone rings. It's an interruption demanding your immediate attention. You have to put the book down, answer the phone, and deal with whatever needs to be dealt with. That's essentially what an interrupt is in the world of programming. It's an event that requires the program to stop what it's doing and jump to a specific section of code to handle that event.
Okay. So in our traffic light scenario, pressing the pedestrian button is like that ringing phone, interrupting the regular flow of traffic.
Exactly. The Arduino is happily cycling through its, red, yellow, green sequence when suddenly, bam, the button is pressed. This triggers an interrupt, forcing the Arduino to pause its regular loop and jump to a special section of code designed to handle the pedestrian crossing request.
So what happens in that special section of code? Does it just you immediately switch the lights to allow pedestrians to cross?
Not necessarily. It needs to do so safely. That's where state machines come in. Imagine a traffic light has different personalities or modes of operation. It can be in a normal state, cycling through its regular sequence, or it can switch to a pedestrian crossing state, where the priority is to allow pedestrians to cross safely. This state machine helps manage these different modes, ensuring the traffic light behaves appropriately in each situation.
So it's like a set of rules that govern how the traffic light transitions between these different states, depending on the input it receives.
Exactly. It ensures that the traffic light doesn't jump erratically between states. It transitions smoothly and safely, taking into account the current state and the input from the pedestrian button.
Now I'm starting to see how these concepts, interrupts, and state machines work together to create a more complex and responsive system. But how do the kids actually implement this in their code? I'm guessing it involves some new programming techniques.
You're right. They'll be learning about specific functions and commands that allow them to work with interrupts and state machines. For example, the attach interrupt function lets them specify which pin on the Arduino is connected to the button and what code should be executed when the button is pressed. They'll also use conditional statements like if and else to control the flow of the program and determine which state the traffic light should be in.
So they're building upon the basic coding skills they've already learned, adding these new tools to their, programming toolbox.
Precisely. It's like learning a new language. They start with the basics, the alphabet, and grammar, and gradually build up to more complex sentences and paragraphs. In this case, they're expanding their programming vocabulary and their ability to create more sophisticated and nuanced programs.
This all sounds incredibly challenging.
Yeah.
But also incredibly rewarding. What kind of support do they get as they tackle this new level of complexity.
We provide them with step-by-step guidance, of course, but we also encourage them to collaborate with each other, to share ideas, troubleshoot problems together, and learn from each other's, successes and mistakes. Peer learning is incredibly powerful, especially in a hands-on, project-based setting like this.
It's like they're forming a mini engineering team working together to solve a, real-world problem.
Exactly. And in the process, they're not just learning technical skills, they're also developing those crucial soft skills like communication, collaboration, and problem solving, skills that are essential for success in any field.
That's fantastic. So they're not just building a traffic light, they're building a foundation for their future success.
Absolutely. And it's incredibly rewarding to see them rise to the challenge, to witness those aha moments when they finally, grasp a concept or overcome a hurdle. Their enthusiasm is contagious. And it reminds me why I love doing what I do.
I can imagine. It's about sparking that love of learning, that sense of wonder and accomplishment.
Precisely. And it's not just about the kids. Often we see parents getting just as excited about these projects, rediscovering their own curiosity and their passion for learning.
That's wonderful. It's a reminder that learning is a lifelong journey, and it's something we can all enjoy together, regardless of age or, technical expertise.
Couldn't agree more. So to all the parents out there, whether you're tech savvy or tech shy, I encourage you to embrace this journey alongside your children. Ask them about their projects, celebrate their successes, and offer support when they encounter challenges. You might be surprised at what you learn along the way, both about technology and about your child's incredible potential.
That's a beautiful sentiment to end on. It's a reminder that this is about so much more than just, building a traffic light. It's about fostering a love of learning, a spirit of innovation, and a sense of wonder about the world around us.
I couldn't have said it better myself.
Well, folks, that wraps up our deep dive into the fascinating world of Arduino. We've covered a lot of ground today, from the basic components to the complex concepts of interrupts and state machines. We've seen how a seemingly simple project like building a traffic light can spark creativity, ignite curiosity, and foster a whole host of valuable skills.
It's been a pleasure sharing these insights with you.
The pleasure was all ours. To all the parents listening, thank you for joining us on this journey. Keep encouraging your children to explore, experiment, and create. And remember, you're not alone on this path. There's a whole community of educators, makers, and enthusiasts out there ready to support you and your child every step of the way.
Until next time, keep learning, keep creating, and keep those lights flashing.
That's a wrap.